500 enterprises increase their target and help do business.
Hey everyone, my name is Ravi. I have been in the machine learning space for almost 10 years. Currently working as a manager of machine learning at a company called Overstock. So into the online retail domain. Typically, we use a lot of machine learning, including Gen AI, to automate a lot of processes and make the content on the website better.
I'm Aditya. I work at Google. My work is around applied research that helps deploy foundation models in Google 1P products. New to Google, but before that I spent 4 years working at Nemo. At Nemo I worked on the onboard prediction models and leading two teams, one on training infrastructure and the other on data. And before that I worked on Google Ads again, so been at Google, been at the Alphabet family for about a decade.
Hi everyone, my name is Audrey and I'm with ML Twist. So I've been in data operation for AI for the past 10 years. I was prior to ML Twist at Amazon, Google and Labelbox. I've done a lot of data labeling projects in a lot of different verticals and we can touch on that if we want to. And at ML Twist, we are working on a platform, a no-code solution for automating data pipeline for AI.
Thank you. Yeah, so let's get started talking about evaluations, since Donna was just talking about how difficult it is, and how you have to build some fairly complex systems to really evaluate and know how things are working. And I know, Sai, you've got some experience with this for sure. So I'm wondering if you could tell us, how does your team collaborate? How is this a team effort to collaborate on evaluation systems?
Sure. Since we are building for a lot of use cases, we want to make sure that whatever we are building satisfies most of our end customers. So for that, once we narrow down a set of use cases, then we have to make sure the questions that the user are asking are being satisfactorily answered. And one way to do that is to, in software engineering analogy, we build a set of test cases ahead of time to make sure what we are building satisfies the use case. So the same way we do through a lot of test cases, but more like evals, saying, hey, this is the question and this is the expected answer for a wide variety of variations for each of the use cases. And there are multiple ways to do it. For our use cases, one is directly asking the customers what are the expected questions that they want to solve. Let it give them an alpha to see what are the expected questions they are looking for. And two, in cases where we have the answers missing or where our product documentation isn't providing enough answers, then having subject matter experts provide answers or augmenting the data. And so for creating these evals, either we try to automate it or hand create it based on how narrow and niche the use case is. And again, since Adobe spans across multiple clouds, this approach varies for image or text or video or digital marketing use cases. For each of these use cases, we apply all these approaches, and based on the accuracy we need, we increase the eval set, and sometimes based on the scope of the use cases, we have to keep increasing more. And as we see, as more and more language models come up which are beating the benchmarks, then more eval sets are being created to test the performance of these. So a significant amount of effort goes into building these eval sets. Now that more and more enterprises are working on building agents or agentic AI workflows, a lot of effort goes into building these evaluations for each of these use cases. And the more and the better comprehensive these evals are, the better we will be able to build our agents and iterate faster on them.
Yeah, thank you. So it's really a matter of tying them closely to the use cases and then continuing to maintain and build on them. Makes sense. Yeah, and I know Audrey, you had something to say too about managing KPIs when you're doing all this evaluation. Like, how do you balance the trade-off between ethical considerations, financial considerations?
Thank you. I would say that the KPIs I'm following are the same that I've been following for the past 10 years, which are data quality, which is the number one priority. We want to make sure that the quality is going to be really high. But it's not enough. We need to understand also in terms of budget, how much is it going to cost? That was part of the previous conversation that was happening, right? On the last panel, how much is it going to cost? What is your budget? And then it's going to determine also the volume of data that you're going to be able to access. And that means also that it's going to be connected to the data quality evaluation that you're going to put in place. Are you going to be able to do a thorough quality control check on a sample or the entire data set, or what are you going to put in place? And the last KPI is the timeline. Are you in a rush to train your model? Do you have 6 months to get your model to production? And all 3 KPIs are, in my opinion, very important, and you need to get that straight before starting any evaluation to make sure that you're going to be able to deliver what is expected.
Yeah, so a lot of considerations to balance there, for sure. And one thing we haven't really talked about yet today, but I think it's pretty interesting, is when it comes to either training or evaluation data, what is the role of synthetic data? And I know, Ravi, we talked about, we talk about synthetic data at a kind of a high level, but really we're talking about a lot of different things, right? Like, so what exactly is synthetic data?
I think that's a name that has been coming more often and often in the few years. I think synthetic data, to define, is very similar like other data, except it is just generated artificially. So these data points, be text, can be generated for LLMs. If it's image, it can be generated using models such as GANs, or if they're like video that are needed for training the model, then these are can be generated by diffusion models or maybe Sora models. But I think one thing that we need to understand is these synthetic data is not exactly similar to augmented data that was traditionally used in our traditional ML, or maybe anonymized data. These are data points that we need to augment or to train our models. And I think primarily when I looked 5 years ago, when I was working at a company in the insurance space, we were training a lot of these models on house data for segmentation. And one of the things we did not have access to is photos inside of house across the US. And that was a very, very limitation that we had. Now, how do we go past this limitation? The models have become much more complex, that they are able to kind of give that data to us. And this does 2 things. Number one, easily get access to data. And I know that, getting access to good data in an enterprise is a very, very difficult task. The second is the cost to getting that data has also come down. Like, for example, if I have to go and hire data labelers to get this data, or maybe get images by clicking or for doing Photoshop, that is going to be pretty expensive at the scale at which we need to train these models. But when we look at the synthetic data landscape these days, these 2 pieces are very, very important nowadays. In fact, while coming to this talk, I was reading an article on Gartner, and it looks like by 2030, it seems like almost all the data that will be used to train these models will be synthetic data. So I do believe that a lot has changed, and I believe that these complex models will generate much more quality data, which will be used much more widely going forward.
Yeah, that's interesting. So just more and more synthetic data. This on again? Yeah, more and more synthetic data. Then yeah, it's really trending that way now. So you know how I think we still don't use all synthetic data though for any given use case. And so Aditya, I was wondering if you could tell us you know what your experience with synthetic data is and how it maybe fills gaps in data that's otherwise available.
Sure. Okay, I'll start by stating the obvious. Like data and eval is the fundamental to ML models. And I would joke with a friend that as long as I can get the data and enough evals, there are lots of PhD students who can get me the best models they have. And just more mathematically, you can say that your model is a compressed version of the data that is trained on. Now, when you talk of data, what are the key problems? That as was said, like it's hard to get data, especially in a very balanced way. In some cases, you just don't have data. Like imagine a language model that wants to cover all languages, and there's not enough data on certain languages in the world, but you still want to perform well. So there is an element of data balancing here. There are other scenarios that you want to do well on, but that don't happen very often in real life. Right? This happens very often in the case of autonomous vehicles. So you want to cover those examples to do well. And even in what is agentic systems, where you want a model to be able to invoke your API. Now, the model needs to learn on exactly what the API spec is and how to fill each field, which means what is the semantics of each field. This data is not readily available. So often you need to work with synthetic data to augment your data, where real data is hard to generate or too costly to generate. Now, with respect to evals, I think all of these points stay, but there's a critical element of safety. There are safety specific considerations on which you want your models to do well, even if they are not part of the training data. Now, there I can build targeted eval sets using synthetic data and make sure that my models perform well. Maybe a third element is that what about synthetic data in RAG systems? There's really two key characteristics of a RAG system that makes synthetic data very important. I think this came up in the previous session as well. But most people trying to build a RAG system have a huge corpus of data, but no real life good golden examples. Very few people come that I have these really good triplets of corpus, retrieve documents and golden answers, and let's now go build a system and evaluate it to do well. So in such limitations, and the other characteristics become that you really don't want your RAG systems to hallucinate. That is why you are building a RAG system. So in order to build alignment or instruction following, that it's better to say that there is no answer than hallucinate an answer. I often need to come up with data examples. And there's a difference here, that this is not about improving the model's ability on factuality. It's really about alignment and instruction tuning. Now, that being said, synthetic data is also something to be wary of. So what are the engineering challenges that come with synthetic data? I'll probably emphasize on one, which is that given how critical data is also the fastest way to screw up your models. If you have, if you get your data balancing wrong, you can end up with take a simple example of driving. You want your driving models to do well in very complicated scenarios. So you want to focus on that. But if you end up with too many complicated scenarios of driving in your data set, even on simple scenarios and roads, your car starts behaving in very complicated behaviors, which is not what you want. Right? So data balancing really becomes critical. Other than that, infra challenges of scaling data, I can go on and on about that, especially data scaling and so on. But I'll leave that for follow-up questions if folks are interested.
Yeah, thanks, Aditya. And yeah, I really like I like it when it comes back to self-driving examples too, because I have to say, like personally, I've only worked on fairly low stakes situations, but it's the people who've worked on self-driving who have really had to tackle these problems for real. Yeah, so all of this data, of course, as we've been alluding to, requires labeling, and we are seeing more and more automation of labeling to enable doing it at scale better, but I think we're still kind of in a transition period, or still kind of exploring how that's really going to work. So I'm wondering if maybe Sai, you can start by talking about how your strategy has evolved in recent years for data labeling.
Sure. Most of these AI models and language models, as well as image models, need a lot of label data to do really good from text to image or image to text kind of scenarios. And Adobe being one of the primarily creative companies, we do have a lot of use case for label data, and we have multiple approaches. One is using the existing label data, but there's always the need for more data that's labeled for, especially for use cases which is not readily available, or some other dimensions, or some niche use cases where that's applicable only for certain segments or certain dimensions. So in those cases, either we are using model-based labeling, where the AI is helping with labeling, and then there's some amount of human verification. So this is one scalable approach, because we can only do up to a certain extent by using human labeling. And if we wanted to scale it to hundreds or thousands of images, we have to use a combination of semi-human plus AI labeling. Either it's extracting some sort of metadata from existing images and then applying multiple layers of validation, and then in cases where we have less confidence or threshold, employing humans to validate it. Or again, even in human validation, there's certain forms of bias, so making sure all that is accounted is one of the challenges. And then we have the same challenge for text to video. A lot of new models are coming up for text to video, but this needs extreme large data for again labeling as well. And there's a huge number of opportunities for different startups as well as companies to address these, as we need cheaper amount of work needed to get this data, so that we can train more and more efficient models.
Yeah, I think in my time working in the ML space, I've seen the data labeling transition from human annotations to what everyone is now offering, AI-assisted labeling. So if I look back, like again, 5 years, almost all the data labeling that we were doing was almost all human manual annotated, and that costed like thousands of dollars to do so, especially since I was working in the image space. Whereas now, doing basic things, not basic, but doing complicated things like doing segmentation of images and videos, optical flow, all of that, a model such as SAM2 can do for us. And this was not even possible, or not even, I could not comprehend like 5 or maybe 10 years ago when I was starting in the field. So, again, more so to happen in that space. The only thing that I feel is sometimes these models are sometimes not reliable, because it's obviously the stochastic model. But with right prompt engineering and maybe with the AI, like Aditya talked about, AI infrastructure, with these models inference becoming much cheaper going forward, there's a lot of scope in using these as data labeling systems.
Yeah, and I think that's the question that we face a lot, is how good are LLMs at labeling data, and how much can we rein them in when we see them not quite performing how we expected. And I want to open it up either Audrey or Aditya.
Yeah, I can just chime in very quickly. I think, I mean, at MLTwist we work on like audio, video, image, 3D data, and we are trying to use models for pre-labeling. And I think like for use cases that are quite simple, where the data is clean, it works, right? And you can have a little bit of human in the loop just to make sure that everything is working correctly, but not so much. But we're working also on very raw data that's like not good quality. If you think about drone videos, if you think about geospatial data, and in that case, we are trying honestly, because that's the future and that's going to happen in the upcoming years. But as of right now, it's very counterproductive. It costs way more money to actually use pre-labeling than to just use human from scratch. So we're getting there, but like there is still like a lot of use cases that would use humans as the core of the labeling.
Yeah, and I think I'll just add that often data quality is more important than data quantity. Right? So just to, like, synthetic labeling is amazing. It's a very powerful technique, but it's not a solution in itself. You can't magically expect data sets will be created for you, but if you find that there are certain gaps in that data, you can use it as a technique to address those gaps, often with some amount of, so it's kind of shifting left in terms of the effort and work required, but done without caution, it can also be quite harmful, is what I meant.
Yeah, thanks. That's the challenge, is how do you make it LLMs all the way down? And maybe that will probably never happen, I think, but we are seeing some interesting developments. So I think I want to break now for questions so that we have time before 5 o'clock. Are there any questions from the audience? And this would be on data labeling or evaluation. Yeah, Alice.
Hi. Full disclosure, I'm from Athens. I have some questions about labeling. We typically work on like human labeling most of the time, and we're looking into AI augmented labeling rather than AI labeling. So I hear from your experience that it's very tempting to do full steam AI labeling or AI synthetic data, but then I also hear, oh, wait a minute, it can be like sometimes kind of like disrupting to the results, the quality, etc., etc. So I think I have multiple questions here. One would be, what is your threshold on saying like, oh, for this type of project, maybe data annotation, something very easy, straightforward, dog, not dog, for images, and maybe sometimes something more complicated where you have to evaluate sensitivity of content for text in different languages, let's say. So what should be your threshold for saying, for this we can use full AI annotation, and for this we shouldn't? And maybe also what is your trade-off between like the cost and the risk between, let's have an LLM annotating everything, but let's have human in the loop for when it's like more touchy. How do you manage that in your day-to-day projects? Yeah, I know it's hard.
Sure, I can take a shot. I think, as Aditya mentioned, LLMs or all these models are not there yet where we can 100% rely on what they give to train these models. So there has to be a balance between how much we are using these models for. But I think at the same time, there are a couple of tasks that are very, very easy for these models to do. So for example, let's talk about object detection. That's something that my team does a lot. For object detection, these models have been trained on so much data that they are really good at what they're doing. But maybe, if we are looking at a different class, that these models, although these are zero-shot models, a lot of them, maybe some of the detections, they're not that good. And that's where we really want to add that manual component, so that we really want our model to cover all the bases rather than just being good at one place and, kind of, to be like in words, sucking at other places. So I guess to answer your question, I hope that answers it. It's just basically, it always has to be the eval component and looking at the data. So first of all, we really want to understand what is the task that we want to achieve, and then kind of make a decision how much human plus how much AI assisted we are looking to use for that task.
Okay, so you have to put in place a system where you can say this label that is output as a model, I don't have the level of confidence to trust the prediction of this is the right label. So how concretely, how you implement this choice in your day-to-day project? Like I use a model to label data, but I know some of the prediction for label are not really accurate or trustworthy. How do you know that? How do you make the difference?
So mostly by doing like a POC. So for example, if you're doing a POC, I'm pretty sure like we used your services before. So, we most likely will start with a POC with these providers, and then let's say we give them a sample data, and then, kind of get a metric on top of that. And then, my team will basically evaluate how much that metric stands true. And the idea is kind of to give a representative data for getting back rather than just being, in from one bag. So that's what typically what we use as a metric for, this strategy.
There's no one answer, but one technique that works is that it's often easier for a human to curate 100 good examples out of 1,000 machine-generated examples than to actually generate 100 examples from scratch. So that's one. But personally, I'll be hesitant to do modeling work on data that is 100% synthetic generated, and in fact I'd be curious at that point, is that not distillation more than modeling? Which for efficiency reasons makes sense, but will I get any new capabilities by doing that?
Yeah, thank you. Yeah, I feel like a lot of times it's the how well defined is the problem before you can hand it off to an LLM. If you're not really sure what you want yourself, or if the data isn't really clear, then you're probably going to not get the results you want just magically.
I think the only thing I want to add here is the expectation versus reality thing.
Yeah.
Where I guess if I open my LinkedIn, it's just full of LLMs doing all fancy stuff, just replacing coding systems like I've used Cursor, I've used Codium, Windsurf nowadays, or LLMs, and at all these big conferences, when the C-level execs go, they are just bombarded with so much fancy stuff, and then when they come back, the directive is, let's just use these LLMs and replace everyone. And to be frank, that is not what we see on the ground. Data is very messy, and to your point, this has to be human component still. I was at a talk at Netflix a couple of months ago, and even at Netflix scale, they really they can afford so many people, and almost all the AI system that they're building has a human component to it. So I think we are at not that scale where we can rely on AI systems 100%. There has to be a human control, maybe prompt or prompt engineering, whatever we can call it.
I think we just need to keep in mind that there is limitation to whatever we're gonna try to do. Either you go with synthetic data or even labeled data by humans. I was talking with a friend in the healthcare industry, and he was saying great. We hired all these people to label the data, and they are like PhD in whatever, and they are physicians, and we don't know if what they are labeling is true or not. And that creates another problem where you need to come up with some sort of like evaluation of even human input. And so it's very important, especially for self-driving cars, or like, as you said, for high-stake projects, to keep that in mind, that there is no source of truth that's 100% true.
Yeah, so I think if there's one more question, we can take that.
I have one more question. Sorry. I think I'd like to go back to like just what you said, and also because we have a great panel, I have a ton of questions. But so there is no trust, kind of like there is we have to trust that people who are subject matter experts are annotating the data in the perfect way, which is very tedious indeed. And so that's why we often use like agreements between SME to make sure they all converge toward the same labels, the same categories, same prediction. And then we use that expertise to like distillate or to like model what we want to build with AI. So I think one of the issues we have at Twist or Labelbox or Apple or whatever, when we work on delivering high quality data for you guys when you're building model, is to try to get a sense of what you name qualitative data and how to measure that, besides just having agreements between experts or having high confidence from model prediction. What do you consider being high quality data to feed your model?
Yeah, so what is the final check?
Yeah. Tell us.
I think I'll again talk briefly. The final check might be the eval set or the validation set. If that's something that we most likely do in-house, and then compare from on the model that was trained on the trained set. And oftentimes it's very difficult, but that's something that we have to do a lot. And also, I think, just to briefly add to your point, it's very important to give the instructions very right to the data labelers to get really good quality data. And you really have to spend to get that comprehensive guide, because at the end of the day, the folks who are labeling the data, they don't know your data. So you have to explain to the core what they have to do, what to do in terms of when a confusion happens, or disagreement happens. And oftentimes we have a channel open with the data labeling folks, where we can answer any questions that they will have, because obviously these are on this panel, if there's a data labeling task, pretty sure like we will all disagree on at least some of those questions. And those are the edge cases that we really want to kind of make sure we get it right. I guess I just...
All right, thanks, Robbie, and thanks, everybody. I think this was a really informative discussion. Really good to hear from all these different viewpoints. And I think I'm going to hand it off to Dave to wrap up.
Yeah.
All right. Thank you.
Thank you.